We're going to build a QBSA, QRP base station accessory. Stephen Weber puts the kit out, and it's the big brother to the freaking digital dial that I built earlier. This has a digital dial built into it, along with a 10 watt meter, forward and reverse power meter, and a 2.5 watt audio amplifier, and a voltage regulator on board. So it comes in a similar package. We open it and there's a lot more parts in it than the digital dial had. We have a CD that's got the manual on it. We have the printed circuit board. Going to have parts on both sides. It's a divided board. It's going to break apart right here along the line so that we have a display board that's vertical and the horizontal board that has the main components on it. We have some coaxial cable. The ICs, and we have some sockets for them, which I like that. I always recommend putting ICs and sockets because it makes it a whole lot easier to replace the components. And we have a packet of hardware here, through-hole components and surface mount components. So this should be a very comprehensive kit, should be a lot of fun. I had a lot of fun building a digital dial, so I'm really looking forward to building this also. The first step in the manual says to separate the display board from the main board by gently snapping it along the lines here, so we'll attempt that. I'm going to just push down, and that worked easy. So sometimes I'd be somewhat nervous about breaking a board, but it had already been routed and scored to where it worked real easy. Next thing, it says to insert the board mounting standoffs in the four corner holes. So we're going to assume this with all the writing is the top, and this is the bottom, and these are what the four standoffs look like. So we're just going to press them in. Press them in, they go in, they fit snug so they're not going to fall back out. I'm going to turn the board over. Then I'm going to have to turn on a higher wattage iron than what I use for the surface mount, because it says to run a bead of solder around the edges here. We'll just run a small bead of solder here. You don't need to run it all the way around because, oops, and it fell out. We don't need a lot of solder here. We just need something to hold it in place. A little bead on there to get a little heat transfer going. And it fell out. That's the second one that's done that, so we need to redevelop the procedure a little bit. Since they'll fall out, because what's happening is when you heat them up, the solder that's on the inside of the hole heats up also, and it releases the stud. So it's no longer a snug fit. So what I'm going to do is I'm going to do it upside down. There's no reason why you can't solder it on the bottom side as well as the top, because this plated through a hole. Okay, you can take advantage of my learning mode. Put the inserts into the board and turn it upside down to where you're working with the top there, yet they can't fall out because they're down against the bottom of the box. Now I should be able to just solder these on without any problem. My iron's not quite hot enough for the job, but I have solder filled it all the way around, so that worked fine there. Getting these in were a real problem because I had added solder. So I had solder on the inside of the hole. I had solder on the outside of the standoff. So things really didn't go back together nice. Could use just a hotter iron. This iron is one I use on printed circuit boards, and you have to heat that whole standoff off. So I got that all done. So I'll finish the other two, and then we'll proceed on. We're going to start by mounting the surface mount components on the bottom of the board. The resistors have the values marked on them, so there shouldn't be any problem at all. The other devices are color coded. The procedure says to start with R1, 2, 3, and 4 first, so we'll do that. First step we're going to do is put a little dab of solder on each of the pads, on one end of the pads that we're going to solder. We'll do these 4 resistors first. And if I look shaky, that's because I'm soldering in the viewfinder of the camera instead of looking directly at it. So there we've got a little dab of solder there. The next step is going to be to position a resistor there, hold it with a pair of tweezers, and then heat that dab of solder to tack that resistor into place. You need a good magnifying glass to be able to identify these, because these are small. These are 100 ohm resistors. So if you have a 102, that would be 1 0 with 2 more zeros, so it would be 1,000 ohms. So 1 0 0 with a 0 is a 100 ohm resistor. Okay, we're ready to try to attempt this. I've got a hold of it with my tweezers. I'm in my box, so if I drop it, it won't go anywhere. And I've tacked that in. Once I've got that in tacked, now I can come back to the other end and solder that. Then I'll come back and add just a little bit more solder to the first end. I'll inspect for a solder fillet later. So we got one on. Like I said, it's difficult because I'm trying to solder it and the camera's in the way. So here we go with another one. It's in position. Tack it. It is tacked. Solder the other end here now. Add a little solder to the first end. I'll inspect these with my microscope after I get them all done, because I can't see good enough while I'm soldering here on the video. We'll do one more here. Take them out of the packet, turn them right side up. The back side is all white. That one's got to be rotated. You want the markings all to be the same direction. Doesn't make any difference, it just makes it look more professional. Holding it in place. Tack it. We'll add a little solder. Solder the other end there. Add a little solder to the first end. Put one more and we have all the 100 ohm resistors in place. And it's just as easy as it looks, actually. For you, if you got a magnifier, it's going to be easier because you're not messing with the camera and trying to do it on the display of the video camera. There, that's got those four in. Next we're going to do R5 and R8. We'll see if we can get R5 here. I want to get the pad down at the bottom. I want to get that one down there. We'll put some solder on it. Have the solder bead. Now I have to rotate it to get it around to where I can come in from one side with the tweezers and hold it apart. This one's smaller. Than the others. So this will be a little more of a challenge here. I lost it on the board. There we go. It's in position. It's tacked. We'll get the other side now. Come back, and I'm not going to add a little any on that. I think I'm going to leave it alone. When I looked at my other solder connections on the first four with the microscope, they looked pretty good. So I'm going to just leave that one alone. So we got R5 in there. Except, if you notice, I didn't line the numbers up. They're upside down from the R1 through R4. But I'm not going to try to take it off, so I'm going to just live with it. So next thing, we're going to need to find R8 here on the schematic. Found R8. Now to get into it. I have my solder on there. How to get it right side up. I'm going to have to move the board of the box to do this one. Okay, got it positioned in place. Tacked. And solder. I'm going to go ahead. You've seen this operation now several times, so I'm going to go ahead and do it and get more components on. If I find something unique, I'll come back and we'll videotape it. Soldering in the transistors and the JFETs is a little harder. Here I have Q2 I'm getting ready to put in. It's currently upside down. Now, about the only way you can tell is the leads stick up above the board. And it's really hard to see that in this, in what I can tape here. I'm going to see if I can turn it over. And I haven't yet. Kind of chasing it around. It hangs on to the end of my tweezers a little bit. Let me get something, see if I can push it off. It's still upside down. I kicked it off the board, but it landed right side up. So there, it's the right direction. Where it needs to go is over there, right next to where it is. So the first thing to do is put a little solder dot there. Okay, and now we'll see if we can move it over. I'm not going to try not to use the tweezers there because they seem to stick and hold it. So it's pivoting around the solder dot. I'm going to have to grab a hold of it with the tweezers. If I can get a hold of it end to end. Okay, and it is right side up. I can't get my hand in there because of the camera. Okay. It's tacked on one side. Need to move the lighting so we can see the other side. I'm going to go ahead and move back to my microscope. You've seen the problem here. So you've got it right side up because you can see the lettering on the top of the device. So that's as good as I can get as far as showing you the process here. Maybe we can do some with the ICs, but I just don't have the ability to do it here with the transistors. We're going to try to solder the IC on now. If we take a look here, here's a notch for pin 1, so pin 1's going to be right here. So with this particular IC, if we turn it around here, the bevels, there's a big bevel on this side and there's not a bevel on that side. So if we turn it around, and I just knocked it off the board. So at least it came back the right way. We'll find that the bevel side is pin 1, so when we get the bevel here, this will be pin 1. And also, manufacturer's logo, if it's printed, this is also be on the pin 1 end. Here's the logo, so this has got to be pin 1 there. So what we want to do is put a dot of solder on one pad. So we're going to tack one side, then come back and tack the other side. So the first thing we want to do is put a little dot of solder here. Now we'll move the IC over into position. And we're going to tack that. Check for alignment. That's pretty good, it looks like. So I'm going to tack that pin there. I got solder to tack. Now I'm going to take and push down on the IC and reheat that tack connection just to make sure the IC is down tight on the board. Now I want to examine all the pads to make sure that everything is right where it belongs. Everything looks okay. Now it's just a matter of applying a little solder to each pin. I can't tell how good a job I'm doing here in the camera. So I think what I'm going to do is, I've got it in position, everything looks good, I'm going to go back to my microscope to do the final soldering. Or maybe let's see if we can do a couple more here. I always touch them up under the microscope. I'm using 0.015 solder, which works good because it gives me a lot of control over how much solder gets on the actual connection. So it looks like I've got them, so I'm going to do the other side because the back side's hard to reach because of the camera jig. So we'll go ahead and do that under the microscope. We've completed the assembly of the surface mount components. These are the components that are on the top of the board. And if we turn it over, we have more components on the back side of the board. The next part of the process now is going to be install the through-hole components. So we'll go ahead and work on that now. Okay, things are moving along pretty good. I got a little confusion here when I wound my ballon, so I'll try to unconfuse you, or hopefully it won't make you more confused. So we're going to start with this winding right here. It starts winding at the bottom and bottom of the core. So if you clamp it in a vise or put it in something to hold it, you take and pass one winding through, and the next winding that comes through, as it loops around, should be on above the first winding. When you're all done, you'll have 10 passes through the core, and you'll have 9 loops on the outside. And the finish one should be higher up the core from the bottom, because you start at the bottom and each winding will progressively move up on the core a little bit. Okay, then on the next side you're going to do the same thing. Remember, we're going to measure forward and reflected power, so this one has to be 180 out of phase with this one. So we're going to start on the bottom of this, run one pass through, bring it around, then come over the top of this start. Then we'll run another pass through and bring it around and bring it over the top of this, the one we just finished, until we end up with 10 passes through the core and 9 windings shown on the outside. So once you've got all that wound that way, the next step is to put it on the board. We're going to position the core on the board and so that we end up with one bottom winding down here in this center here, and on the other side the other bottom winding that ends up over here. If you look at the board closely, you'll find that these two bottom windings are actually grounds. So then the top winding, this is going to be one top winding here, come from the core over here, come over and solder to this point. The top winding on the other side is going to come over and solder to this point. So if you look at the schematic now, what we've done is this side is going to be 180 out of phase with this side over here, and the two center ones, which were the bottom windings on the core, this is a bottom winding, and this is a bottom winding. Those are grounded, and coming off the top sides, this would be the top of one side, this would be the top of the other side. Now all we have left to do is put our one turn primary through there. So we'll do that, and I'll show you how that looks when we're done with that. Okay, the next challenge is going to be to insert the Teflon wire through the core. The way I did it is I cut an 1.25 inch piece of the Teflon wire. I stripped each end back just a little bit more than a quarter of an inch. Then I tinned it. When you tin it, be careful that you don't get too much solder on it, because it does have to go through the hole. Then just take and bend a 90-degree turn in one end and feed it back through the other way. Now once I've got it through there, I can grab this tinned end with my needle nose, push it down into the board. Once you get it in, reach down in from the other side, grab the loose end and pull it down, snug it, then bend it over a little bit. So now all we got to do is come back on the other side and put a bend in. Be careful not to break our other wire. Push it down through. Come on, go. Grab it on the other side and pull both sides snug. Now that you have all that done, you notice I still have the tails on my other windings. I haven't trimmed them off. Before you trim them off, go ahead and use an ohmmeter and make sure that they have continuity through, that you got it hot enough. The magnet wire I got was heat strippable, so hopefully you'll have that. That makes it a lot easier. So that's the balun. That's the way it's going to look when it's all done on top. With the soldering on of the balun, we've completed the top of the board. We could put RCA jacks there. They were furnished. And if we were going to do that, we'd just mount them on just like that. I'm going to leave them off for now because I'm probably going to mount mine inside another chassis, another box, and I want to put those on the outside. So it's been fun getting to this part. No great exceeding difficulty, and all we have left now to do is the display. Okay, we have it assembled. Now we're ready to test it. Procedure says before I install the ICs, connect the power, and what we want to do is check for 5 volts on pin 1 of U3. We'll pick up a ground out here on the side, and here's U3 down here. Here's the notch right there, so this is pin 1 right there. And we show 5.2 volts there. So the 5 volt regulator is working. Says we can also test the output of the variable regulator. I'll just pick up a ground here. And V out's right down here underneath. Get my hand out of the way. Adjust it all the way down, and I have 6.1 volts. And adjust to 10.9. I've only putting in 13.3. So there'll be about a 2.5 volt drop through the regulator. So that's working fine. This will give us a good source for 9 volts or some kind of variable voltage, as long as I don't try to put too much current through it, because I don't have a heat sink on the regulator at this time. Next thing we can do is plug in the ICs. Okay, we have the ICs plugged in. Now, the next step could be dangerous in as much as I haven't powered this up with the ICs on yet. Other than I plugged in the audio amp and tested that. So hopefully we won't get any smoke. The procedure says when we reconnect power, display will come on and show all 8s for a few seconds. Then the displays will go to all 0s. When I did my digital dial, I connected up, didn't watch quick enough, so I never saw the all 8s. So we'll see if we get it this time. We'll do it on 3. 1, 2, 3. There's all 8s. And now we have 0s. It's a little hard to tell with all the light that we've got showing on here. That shows up a little better. So it's reading 001.2. Except I did it and it's upside down to U. Oh well, we can't do that again. I'll turn it off and we'll turn it around and try it. That turned off. We'll rotate it. Guess can't win them all. Hey, we got 8s again, so that's okay. And our 0s. So that's better. Now we can hook an audio input into it and plug a speaker onto it. Okay, I've connected my signal generator to it. And I've connected speakers, so we'll turn the volume control pot up. And we have audio amplifier. So that part works. Okay, we're going to calibrate the frequency counter I've got 20 megahertz in, and I'm going to adjust faster till it reads 20. And getting close. That's went a little bit too far. That's pretty close. Let's change the frequency slightly. That's 0.9 of 18.9 in there now, and it's flipping between 0 and 1. We'll go down and increase it to 5 kilohertz. Reading 19.0. 5 is slipping between the 5 and the 4.9. So that's pretty good. I'll say that's fine.